Somewhere past the edge of what we can currently build, there's a machine that could end travel as we know it. Not by making it faster, but by making the distance disappear entirely. Step in on one side of the planet, step out on the other, never actually cross the space in between. It sounds like magic, but it isn't. And once you understand what a machine like this would actually have to do to make that happen, you might find yourself hoping it never gets built. So I started digging into how something like this would actually have to work. I want to find out how the actual physics of teleportation would play out in the real world, as opposed to how the movies portray it. And the deeper I went, the less it looked like a simple walk-in, walk-out scenario like a train, and the more it looked like something else entirely. Here's the thing that stopped me. Nobody serious who works on this problem thinks the machine would move you. They think it would have to rebuild you. And the problem nobody solves in the movies, you can't just beam matter across a continent. Physics won't allow it. So here's what a machine like this would actually have to do. 1. Scan every particle in your body, billions of data points down to the quantum level. 2. Destroy the original instantly, because there's no clean way to duplicate someone while the original still exists in that state. 3. Transmit the data, not the matter, to the destination. 4. Rebuild a new version of you from new atoms using data from that scan as the blueprint. 4 steps. That's the entire trick. Now zoom out for a second, because this is where it stops being an engineering problem. Every atom in your body right now isn't the one you were born with. Your cells replace themselves constantly over your entire life. You are already quietly being rebuilt one piece at a time, and you still call yourself you through all of it. So maybe a machine like this wouldn't be doing anything your own body doesn't already do, just all at once instead of gradually over 80 years, or maybe that gap between gradual and instant is exactly the thing that matters. Nobody actually knows which version is true. Not the physicists, not the philosophers who've been arguing over this exact puzzle for more than 300 years, long before anyone had a machine to test it on. What we do know is this: we're racing towards a technology that quietly asks us to answer that question, whether we're ready or not. And next, we're looking at the one scenario every engineer hopes never happens. Here's a word that never appears in the safety manual: murder. And no, not as a metaphor. Every time that booth activates, something with your exact molecular structure is destroyed on purpose so that a copy can exist somewhere else. Call it whatever the marketing department prefers. Physically, it's still an ending. This isn't a design choice. It's a law of physics called the no cloning theorem, and it isn't optional. 1. Quantum mechanics forbids creating an identical copy of an unknown quantum state without disturbing the original. 2. That means a scanner can't examine your exact atomic structure and leave it untouched afterward. The act of measuring it changes it. 3. So there's no version of this technology where a perfect copy exists while the original quietly walks away intact. 4. Every teleportation concept that has ever appeared in a serious physics paper requires the original's destruction as a mathematical necessity, not a marketing decision.
When it comes down to quantum states, there are physical rules which say you cannot copy them. If I take a superposition state of a 1 and a 0, I have to choose a measurement basis in which to measure it and project it into 1 or 0 state.
Philosophers have argued a version of this problem for centuries using a ship instead of a person. Replace one plank and it's obviously still the same ship. Replace every plank one at a time over enough years and something starts to feel different, even though no single moment marked the change. A ship doesn't mind either way. It has no experience to interrupt. A person does. And that's exactly where the comparison stops being comfortable. Here's what actually makes this difficult, not just unsettling. The copy that steps out the other side doesn't experience anything happening. It remembers walking in, it remembers an 11-minute wait becoming 11 seconds. From the inside, there's no gap, no interruption, nothing that felt like an ending. But from the outside, looking at the booth where the original stood, something did stop. Both of those things are true at the same time, and physics doesn't offer a way to pick one. Every safety report on record insists this happens in a strict order: destruction first, reconstruction second. No overlap, no exceptions, but every report on record is carrying a lot of weight in that sentence, because there is exactly one situation every safety engineer working on this technology loses sleep over. The destruction step lags by a fraction of a second. The reconstruction step doesn't wait. And for one brief window measured in milliseconds, there are two of you, not a copy and an original anymore. Just two people, both with an equal claim to being real. So how does something like this happen? If the process is supposed to be foolproof, one, every serious safety design builds in a mandatory buffer, confirming destruction is complete before reconstruction is allowed to begin. Two, that buffer typically adds only a few milliseconds of delay, far too brief to notice. Three, under normal conditions, the odds of a true overlap are astronomically small, comparable to failure rates the aviation industry already accepts as routine. Four, but astronomically small isn't zero. At a scale of billions of trips a day, even a 1 in a trillion failure eventually happens to someone. This has almost never had to be tested in court because it's almost never happened. But the thought experiment is simple to state and quite tough to answer. If both instances are physically, chemically, and psychologically identical at the moment of separation, which one gets to keep the passport? The house? The relationships? There's no copy here. Neither one is the fake. They diverge from that moment forward, but they arrive at it as complete equals. And this is the part that's easy to miss in the panic of the thought experiment. Neither version is a mistake. Both are exactly what the machine was designed to produce, a perfect continuation of you. The only thing that actually malfunctioned is the assumption baked into the whole system from the start, that there could only ever be one. Every engineer working on this technology will tell you the same thing. The glitch isn't really the danger is designing a system with a single point of failure in the first place. So the real question was never what happens if it breaks, it's whether there's a version of this technology that couldn't break that way at all. It turns out there might be, just not in the way anyone expects. So is there a version of this that doesn't require an ending at all? As it turns out, there's already a real branch of physics working on exactly that problem. Not in a thought experiment, but in an actual laboratory.
We can use this technique of quantum teleportation. We make a joint measurement of this quantum particle with another quantum particle that is entangled by measuring what is effectively the difference between this particle and this particle.
This is actually where the word teleportation comes from in physics, and it's been misused by science fiction for decades. One, in a real lab, two particles can be entangled, meaning measuring one instantly reveals something about the other, regardless of distance. Two, using that link, physicists have already transmitted the exact quantum state of a photon from one location to another without physically moving the photon itself. Three, this has been demonstrated over genuinely long distances, including from the ground to an orbiting satellite. Four, critically, this isn't moving matter, it's moving information. The particle at the destination isn't the original. It's a separate photon reshaped to match using the entangled link as the blueprint. Here's the honest part most explainers skip. This still requires destroying the original quantum state to read it. The no-cloning theorem doesn't disappear just because the transmission method changed. What's different is the scale of what's being destroyed. A photon's polarization state is a tiny sliver of information. A human body is roughly 10 to the 28th atoms, each one entangled with billions of others through chemistry and structure. Scaling this from one particle to a full person isn't a matter of bigger equipment. It's a gap measured in orders of magnitude. Nobody currently knows how to close. So where does that leave the booth from the start of this video? Firmly in the category of thought experiment for now, every real teleportation experiment to date has moved particles, not people. The distance between the two isn't a matter of a few more years of engineering. It's closer to a gap in kind. But labs keep closing gaps that used to look permanent. Entanglement over longer distances, larger quantum systems held stable for longer. None of it adds up to a person in a booth yet, but it didn't add up to a photon on a satellite either until it did. Now, I want to know if this technology ever matures, if the quantum overlap is solved and the booth becomes as routine as stepping into an elevator, would you actually use it? Or would you look at the math, politely decline, and stick to the slow, comfortable certainty of a car or a commercial flight? Processing the sheer volume of data required to even simulate quantum systems like these demands staggering computational power. If you want to see the desperate high-stakes gamble behind the company building the silicon hardware powering these technological marvels, then check out this video about the chip that held this company's future. Thank you for watching. If these are the kind of stories you're into, engineering marvels, technological success, financial battles, the decisions that shape the world we live in, then do consider subscribing and leaving a like. Oh, and feel free to leave a comment as to which revolutionary technological breakthrough or maybe engineering fail you want me to talk about next. For now, I'll catch you or you'll catch me in the next one. Take it easy.